In this video, we are going to talk about arithmetic sequences. So first we have a little bit of backstory. We have Carl Friedrich Gauss was the first one to sum the numbers counting from 100 when he was a young child. He had added the numbers in pairs, the first and the last, the second to last, so on and so forth. So he did 1 plus 100, 2 plus 99, 3 plus 98, and they all added to 101. So the total will be 50 groups that total to 101, which would be 5,050. So the sum of the first and the last number would be 1 plus the nth number. So we do 1 plus n. And then how many pairs would there be? Well, there would be half the number of pairs. So if I had 100 terms, I would do 100 divided by 2. So the total sum of any arithmetic sequence would be n over 2 times 1 plus n. And this only works for an arithmetic sequence. So assuming a1 is the first term and an is the last term, when we're finding the sum of an arithmetic sequence, we're going to take the number of terms, divide them in half, and then do a1 plus an. So let's use this formula. So a1 is 100, an is 220, and the number of terms is 25. So we're going to do 25 over 2 times 100 plus 220. And this would give me 4,000, would be the sum of all those terms. Similarly here, we have a1, I have n, but I don't have an, so I need to use my explicit formula to solve for an. So a10 would be 8 plus 10 minus 1 times d. Well, to go from 8 to 20, 20 to 32, I'm adding 12. So my common difference would be 12. So my 10th term would be 116. So now when I'm finding the sum, I'm going to do 10 divided by 2, and then a1 plus a10, and that will give me 620. That's my final answer. All right, this third situation is a little bit different. They're giving us something in summation notation. So I need to first determine what's a1 and what's a20, and because I know that my n is 20. So a1, if I plug in 1 for I, I'm going to get 3 times 1 plus 2, so a1 is 5. Then if I plug in 20, 3 times 20 plus 2 would be 62. So I'm going to do 20 over 2, and then 5 plus 62 would give me 670. And this last one says, find the sums of all the multiples of 3 from 99 to 333. So it'd be like 99 plus 3 would be 102, plus 3 would be 105, plus 3 would be 108, all the way up to 333. So first I need to figure out what term number 333 is. So I'm going to put 333 in for, let's use our explicit formula. So 333 is my final term. My first term was 99. I don't know how many terms I have, so I'm going to leave n, but I'm counting or adding 3 every time, so 3 is going to be my common difference. So when I go to solve this, I have 99 plus 3n minus 3, so 333 equals 3n plus 96. 3n is going to equal 237, and so n would equal 79. So now when I go to find the sum, 79 divided by 2, 99 plus 333 is going to equal 17,064. All right, so let's continue to use this formula. I'm going to write it at the top here since we have it on our other page. So find the sum of this series with a1 is 5, an is 65. So now again, I don't know what n is, so I need to solve for n using my explicit formula. So an is 65, a1 is 5, d is 3, and so n would be 21. So I'm going to have 21 over 2, and then 5 plus 65. So it'll leave me with 735. All right, let's try some applications. So if I have a salary of a job is $20,000. So starts at $20,000. This is my A1. You're getting a raise of $2,000 at the beginning of each subsequent year. So this is my common difference. That's how much it's going up by each year. What will my salary be at the end of the 10th year? So that's going to be my N. So we're going to again use our explicit formula and figure out after 10 years, starting at $20,000 and going up by $2,000 a year, how much my salary will be. And after 10 years, it would be $38,000. What would your total earnings be after 10 years? Okay, so now this total earnings means I'd find the sum. So I'm going to use my sum formula. 20,000 plus 38,000 would be $290,000. How long will it take? How long we have to work for to earn 6 figures? So now this is my AN. So I'm going to use my explicit formula and put $100,000 in for AN, 20,000 in for A1. I don't know how many years, so what I'm solving for is N. We're still assuming I'm going up by $2,000 a year. So 100,000 So 100,000 equals 18,000 plus 2,000 N minus the 18,000 over. I'm going to have 82,000 equals 2,000 N. Divide by 2,000, then it would take 41 years. So now it's saying, how long will my gross earnings? So gross, again, this is going to be a sum problem. So it wants to know when your sum will be 1,470,000. So I don't know how many years it's going to take, but I know that I'm starting at 2,000. But I don't know how much my income would be after N years because I don't know how long it's going to take. So let's think about my explicit formula. After N years, starting at $20,000 with a $2,000 increase, that means after N years, if I simplify this, I'd have 2,000 N plus 18,000. And then I have to plug in whatever for N. So I'm going to use this for my AN. So 2,000 N plus 18,000. And now I need to solve for N. So I'm going to distribute this 2N in. So 1,470,000 equals, so if I distribute, that would be 10,000 N plus, distribute it to this guy, that would be 1,000 N squared plus 9,000 N. All right, so let's add like terms, and I see I'm going to have a quadratic, so I want it equal to 0. So I'm going to have 1,000 N squared plus 19,000 N minus 1,470,000. So I can actually divide everything by 1,000, so I'll end up with N squared plus 19N minus 147. Or 1,470, excuse me, if I divide by 1,000. And so we want to think about what multiplies to 1,470 and adds to 19, which is actually going to be 49 and 30, or 49 and negative 30. So that means my positive answer would be 30 years, would be how long it would take to gross $1,470,000. All right, this last question says, the sum of the first 15 terms of an arithmetic progression is 337.5. The first term is -2. Find the common difference. Okay, so I know the sum of the first 15 terms. So I know that if we're going to use our sum formula, my sum equals n over 2 times 1 plus a over n. So I know the sum is 337.5. I know my n is 15. I know my a1 is -2, but I don't know what my an is. But since that's my only left variable, I can solve for it. So if I distribute this in, I will end up with -15 plus 15 over 2an. So if I add 15, and then multiply by the reciprocal, my an is going to be 47. So now knowing that, I can use my explicit formula because that has d in it, and it wants me to find the common difference. So I know 47, I know -2, I know that n is 15, I just now don't know my common difference. So I need to add 2, so I'll get 49 equals 14d. And so my common difference is going to be 3.5.